Oh, there we go. It's working suddenly for no good apparent reason. Stopped working, started working. Fantastic. What? What? Hello, gentle friends. I'll have to leave halfway through this. I may actually just stop when the alarm goes off, but we'll see what happens. There's an update. Last time we did this, it told me that my license was going to run out like 6 days ago. And it asked me today, so we're just going to continue. Let's turn my e-reader on, also known as... So I gave this phone to my dad, because he broke his phone, and I had this phone spare. I said, take good care of it, buddy. Get a glass screen protector for it. And there's scratches. There's a piece of metal fucking embedded in the screen here. What the fuck has he been doing with this? Anyway, it's not the point. Hey, actual people. Jesus, no. You scared me. Don't sneak up on me like that. So the actual purpose of today, doing more C, learning C, proving that I'm not a big idiot. I'm only a little idiot. And yeah, C++, chapter 2. Last time, I think this is the last code that we stopped on. We did something about creating and initializing variables. Some asinine fucking shit about you can't make an int a decimal number. It's stupid. You can't do that, and you can't reassign things. Oh, the thing that we learned was unsigned variables loop through their full range of characters. If you reach the maximum point, if you try and input a number that's beyond the maximum point, they will go to a modulo of the number that you put in, which is very helpful. Very nice, actually. It's a feature that I wish I knew long ago. But you have to specify that an unsigned variable is an unsigned variable. But that's fine. You just write unsigned, and it's unsigned. And anything is an int. That's an integer, an unsigned int. An unsigned char, as you can see here, that's a signed char. An unsigned char is an unsigned character. Compound types. I remember why I stopped. Compound type is a type defined in terms of another type of C++. Oh, right, okay. References and pointers are compound types. Okay, cool. Defining variables of compound type is complicated. Oh. 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 Oh, I stopped last time because I thought it was going to go into a big long thing about compound types and a whole chapter's worth of information about how to make them, but it's just, oh, by the way, references. Oh, no, it's going into it. A reference type refers to another type. Okay, cool. We define a reference type by writing a declaration in the form of and D, where D is the name being declared. Okay, cool. I thought we used the ampersand operator to dereference pointer information. Or is that a second function of this? Is that what this does? There's no way to rebind a reference. References must be initialized. Okay. I don't know why this is all indented. It's not meant to be. Expected a semicolon. Where? Oh, there. It's gonna be right back. I'm back. Just checking the dog was okay. Don't you freak out too. And then yeah. D is duplicate. Oh, it just duplicates the line? Did you auto-correct this for me? Does it matter where that is? Is that going to work? No. Oh no. See, this is what I thought was going to happen. We've got a memory address. 008FF908. That's where boob is stored, right? Something about pointer manipulation. Is that how you do it? Errors. No, that is not how you do it. Is that how you do it? Oh, right. Okay. Yeah, there we go. Somehow it's slam. Someone is slam. All the clocks in this house are wrong. I was freaking out for no reason. It's got loads of time. Yeah, so okay, that works. That's a pretty cool thing to have in the text, though. I think we'll keep that. We'll keep that there. So you can see, oh, it's a different memory address each time. So we print out the int, we change the int, we dereference refboob, a reference to the int. I don't want to say we dereference, actually, that might be bad terminology, but we access refboob, which is a reference to boob, and it gives us 42, and then we and local variable int and refboob. What's this? What's this? What's this? What's this? Okay. I think it might just be a dual use of the ampersand, whereas the ampersand is used for pointer manipulation, right? Reference has been defined. All operations on that reference are actually operations on the object in which the reference is bound. Oh. All right. Yeah. Okay. Look. The book has it in the. Oh my god. Excellent slams. The book has it here, right here. They have no and when they're accessing refboob. And so we can. So this should get out of here. that should work. Should get yeah, boom. So that's pretty cool. I don't know why you'd use this, but that's pretty cool. You can see side by side we got what's going on. You see we've got references printed. We've got int boob equals 8008, int ref boob equals boob, standard console out boob, the int 8008, and then we change boob to 42 and we ask for ref boob, the reference to boob 42. Boom, excellent, and we get the memory address that's stored in. Come back console. It's very good. And then we change the here it is, ref boob equals 8008, so we're accessing ref boob, the reference, and standard console out, and we're asking for the int that the reference is tied to, and it changes them both because the reference is not the int, the reference is the memory address that the int is stored in. And you can use the reference to the int or the int itself to change the value stored in that memory address, right? Am I correct? I feel like I'm correct. I feel like that makes the kind of sense that it should. Very nice. And that's useful because memory references can be used to extract data from a memory location and adjacent memory locations, and skipped through and browsed, it can give you access to the memory directly. Can you use this for like obfuscation purposes, maybe? Excellent, Slam. Okay, what they got here? In I1024, I2 equals 2048. In and R equals I, R2 equals I2. In I3 equals 1024 and Ri equals I3. Okay. The two exceptions we'll cover in 241 and 1523. Whoa. Type of reference in the object to which the reference refers must match exactly. Okay. Moreover, for reasons we'll explore in 241, a reference may be bound only to an object, not to a literal or to the result of a more general expression. Right. So you can't assign input or raw number to a reference, obviously, as we've seen. Which of the following definitions, if any, are valid? Why? Int ival equals 1.01. Int and no. Well, you'll have an int of 1. That's stupid though. Int and rval equals 1.01. No. Int and rval2 equals ival. Yeah, sure. Int and rval no, because it's not initialized. So A tentatively and C. A won't result in a good output though. Sometimes it'll throw that, depending on your compiler, right? That's what we read previously, right? Assigning a float to an int variable is always a stupid idea. I don't know why you would ever try and do that. Why you would ever want to do that. Which of any of these are following assignments are invalid? If they are valid, explain what they do. Int I equals 0 and RL equals I, double D equals 0 and R2 equals D. Okay, R2 equals 3.14159. Yeah. That assigns the number 3 to the double D. God, I can't believe I had to say that. R2 equals RL. You cannot do that because R2 is a double and RL is an integer. I equals R2. Nope, also can't. Oh, you can do that. That will change the integer value of I to whatever R2 is. However, can you do that? That might cause some problems because a double can be bigger than an int, right? RL equals D. Again, you cannot do that because D is specifically a double. And R2 is R1. Oh, it's a 1, not an L. Oh, R1 is specifically an int. So that won't work. Cool. What does the following code print? Int I and RI equals I equals 5. RI equals 10. Wait, what? Int I, comma, and RI equals I is fucking this. No, what? I equals 5, RI equals 10. Standard cout I, RI, this will print 10 and then a space and then a 10 and then it will flush the buffer. A pointer is a compound type that points to another type. Like references, pointers are used for indirect access to other objects. Unlike a reference, a pointer is an object in its own right. Pointers can be assigned and copied. A single pointer can point to several different objects over its lifetime. Unlike a reference, a pointer need not be initialized at the time that it is defined. Unlike other built-in types, pointers defined at block scope have undefined value if they are not initialized. Good. Pointers are often hard to understand. Debugging problems due to pointer errors devil even experienced programmers. Good. This is one of the big reasons why pointers and pointer arithmetic were done away with in a lot of modern, quote-unquote modern, recent, up-to-date, no, what's the word? Baby programming languages? Man, I don't want to be offensive. Like, pretty much everything that isn't C. It's like, pointers? Yeah, nah. We don't do that. We don't deal with memory. Memory is allocated on the back end by stuff that you can't see or touch, which is probably good for most applications, desktop applications, when you've got more computing power than you'd ever need to run the program that you're trying to run, if you catch my drift. However, the problems come when you have either a limitation on the size of the program that you can store, or a limitation on the power of the processing of the program that you can do. So like stuff like modern consoles, even older consoles, a lot of the code would have been, you know, as close to machine code as you can scrunch it, because it's easier for the computer in the thing to deal with that kind of input rather than have a real-time interpreter going, which is why PlayStation 2 emulation only just got good over the last, 2 or 3 years, because it just you couldn't have a CPU fast enough to interpret all of the stuff. It has to take in the code, and then it has to think about what that code does and then do the code. And yeah, it's difficult. Like Python, you don't get to decide how much memory you allocate for each thing. The program allocates memory automatically for you once you've written your program. Python, the interpreter for your program, will allocate memory on your system for you as your program executes. And this may lead to running out of resources, But at the same time, it can also be helpful because it can also clean up for you when you forget to in your C programs. I don't think I've done a single empty memory in this course so far. So yeah. Oh boy, oh boy, oh boy. That cake's gonna be done soon. I'm gonna want to eat it. Shit. Time is going so fast. The second I sit down to do something slow, time goes fast. Here we go. Here is the golden. Here we go. Here it is. Fine, be that way. So this relates back to what we were doing before. I say this relates back to what we were doing before, but P as a pointer to int initializes P to point the object. Because references are not objects, they don't have addresses. Hence, we may not define a pointer to a reference. With two exceptions we cover in 242 and 1523, types of pointer must match to the thing that it points to. But I remember doing this in CS50. You'd have a value and then you'd have a pointer to an address of the value. But you see back in the reference thing, when we make a reference, we use the AND to initialize the reference. So I don't know if this is, well, this is the same thing. Obviously, it must be the same thing because and refbob gives us the memory address to which refbob is stored. Again, just so you can see that. There it is. Which is cool, by the way. Very cool. The value, i.e. the address, stored in a pointer can be in one of four states. Can point to an object, point to the location just immediately past the end of an object. Can be a null pointer indicating that it is not bound to any object. Can be invalid. Values other than the preceding three are invalid. Fuck. We don't want any invalid pointers, so it can point to an object. It can point to the location just immediately past the end of the object. And it can point to null. Here we go, here we go, here we go. When a pointer points to an object, you use the reference operator to access that object. Right, okay. So don't close. Big. I don't want a literal. I want P. And then I want stop P. We'll see what we get out here. Huh. So we get, so the pointer, so when you initialize a pointer with the star, the pointer is the reference, the memory address reference, okay? These are pretty close. These are pretty close to each other, man. They're about 6FFE50, 6FFE38. This is before. How the hell did that happen? Why would you do that? The program runs this way. You put this one here, and then you put this one here. Fucking idiot. Who built this PC? Bill Gates? No, this is Windows 10. Bill Gates had nothing to do with this. So yeah, just the variable, the pointer on its own is the memory address. Dereferencing the pointer with a star gets us the value stored in the memory address, which is omega. Int star equals and omega. As we saw, and ref boob is the address, right? We remember? Man, if I can understand this thing today right now, my brain feels like it's right on the edge of understanding it too. That's good. Anyway, so yeah. So, and omega is the memory address of omega. Initializing P with a star makes it a pointer to and omega. Therefore, the value of P is the value and omega, and the value inside and omega, dereferenced by star P, which is and omega, points to and omega, is omega, which is 42. Or something, I don't know. There's just this weird little kind of reversal act that they do. When you initialize a reference or a pointer, that you put the and reference equals boop, and you put the pointer, the star pointer, but when you dereference them with a star or an and, in the and, you get the address, in the star, you get the contents. But you can't dereference a reference, and you can't point a reference. What? No, what? You can't dereference a reference, and you can't reference a point. No? Yeah? Definitely can't. Yeah. That's what I wanted. Oh, no, that worked. What the fuck? That's not meant to work. Oh, because pointers are objects, references are not objects. So the pointer will have its own memory address, but the reference won't, because it's some ethereal cloud of digits. Let's just leave it at that for now. Let's just using a pointer to access an object. Did that. Yields the object we assign new value to eval through p. So if I were to write star p equals a different number to 42, and then we see out yeah, it would help if I could spell. Thanks for pointing that out to me, Visual Studio. Yeah, there we go, you see. So using references and pointers will always be will change the we'll change the thing inside it rather than the thing. Well, I think if you I don't really want to get into that because that's best beyond the scope of this this short video. I'm not gonna change anything about the address of P or anything like that. That's silly. Why would anyone want to do that? Hacking. That's why they'd want to do it, I'm sure. If you yeah. Null pointer does not point to things. So you can use null Peter 0 or null in all caps to initialize. But you must include cstd lib if you want to use pointer equals 0 to be pointer equals null. Directly initializes pt from the initial constant 0. So that will, yeah, okay. Most direct approach is to use null Peter. Other programs still use a preprocessor variable named null, which the cstd lib header defines as 0. Try the preprocessor in a bit more detail. 26377. It's useful to know. Part of the std namespace. It is illegal to assign an int variable to a pointer, even if that variable's value happens to be 0. Both pointers and references give indirect access to objects. More important differences in how they do so. Most important differences: reference is not an object. Okay, so pointers, if you want to change the address that a pointer points to, you do not use the star in front of it. Let's just null this boy. So that would be p equals null. And then if we were to do something, say like star p equals 9999, that will throw up an error. Boom. Thank you. Thank you. Yes. Exception was thrown. Right access violation. P was null pointer. Thank you. Thank you for telling me. Yep. Big X. Just comment those boys out. What have I done? What have I done? Hey! Yeah, get the fuck out of here. I don't need to troubleshoot it. I know what I was doing. Ah! Ah! Thank you. Well, that's my cue to leave this show for the moment. I will just mute the mic because this is interesting. I think I might just get to the end of this chapter maybe. Back in a few minutes after I have detinned this cake, or at least seen if it's cooked properly. Doesn't look like it's risen very well, but it's cooked at least this time. That's a step in the right direction. Any non-zero pointer evaluates as true. God. What? Okay. Two pointers are equal if they hold the same address and unequal otherwise. It's possible for pointer to an object and a pointer one past the end of a different object to hold the same address. Oh, here we go. The type void star is a special pointer type that can hold the address of any object. That's nice. So if you have a pointer of the correct type, like we have int star p here, you can use that to alter the data of whatever it points to. However, if you have void star p, you would only be able to use the pointer in comparison or dereferencing or the other one, reassignment. So you can't change the contents of your dereferenced pointer if it's a void star, because it doesn't know what type it is, and you have to find out what type it is, and that requires being told what type it is, and that is handled by specified. Get out of here. What? Get out of here. So yeah, cake. It's a casteira cake. Some kind of Japanese, Portuguese, unleavened cake. Filled with sugar and honey. 7 eggs. 7 eggs. 7 egg. God damn it. It's basically pancake batter, but you beat the eggs real hard until they foam up. I like the variable names. Thanks. I'm gonna assume your name is Dumply. It's kind of just a blur on my CRT. You get 9 pixels for each one of those letters. They all just look like squares. Sorry. Thank you. My brain's at about max limit. It's pointer. I've only done, what, 42 to 63, 21 lines of code, and my brain is just leaking out my ears. Why would anyone need to know about pointers, man? Write code to change the value of a pointer. Boom, done that. Write code to change the value to which the pointer points. Done that. Boom. Also commented it out because I pointed it to null right there. And then to check that it was working, I tried to reassign it. My PC almost destroyed itself. it didn't. Visual Studio stopped me before I had a chance to. Explain each of the following definitions. Indicate if they are legal in Y. Int I equals 0. Good. Double star DP equals and I. Oh. No, you can't do that. Int star IP equals I. That's fine. Int star P equals and I. Oh. That's fine as well, right? We have it right there. In fact, that's 100% certainly fine. That's exactly how you meant to do it. But int IP equals I should work. Int star P equals and I. Int star IP equals I. Int star IP. It seems fine. Oh, but because int I is 0, int star IP is gonna end up equal being null, right? That's dumb. Don't do that. Don't do that, kids. Yes, int star IP will end up being a null pointer because it's being. No, it's not. It's what? Well, there's one way we can check that, and it's gonna throw me up. Ah, there were build errors. Would you like to continue with the last successful build? No. Okay, so you obviously can't do that. A value of type int cannot be used to initialize an entity of type int star. Yeah, knew it. There we go. There was something fishy about that. You can't initialize it like that, but you can change it, right? If you have but that's a declaration, so it's definitely wrong. If you were just changing the value of whatever you'd initialized int star IP to, star IP equals value is fine. Otherwise, not fine. Yeah, you can see right there. That's how you do it, right? Int star P equals and omega. Star P was 43. We'll change omega to 43. I lose my mind here. Assuming P is a pointer to int, explain the following code. If P // ... if star P // ... Okay, so they're both infinite loops. If P is evaluating if the pointer is a good pointer, if star P is evaluating if int is a good int. But they're both infinite loops. They're not infinite loops, but they're true. So, okay. If P I guess if it was curly braces, they'd be nested. If they, whatever, I don't care. Given a pointer P, can you determine whether P points to a valid object? If so, how? If not, why not? Given a pointer P, can you determine whether P points to a valid object? If so, how? If not, why not? You can. Yeah, you can. because, oh, no, you can't. Well, you can, but you can't tell what the object is. Even a pointer p can determine whether p points to a valid object. If so, how? If not, why not? So with a pointer p, any pointer, you can assess the pointer covered previously, today, in this page, in fact. If pointer, and if that evaluates to true, the pointer is valid. However, that pointer may be a null pointer. That is a valid pointer. So within that loop, you would have to include code to dereference the pointer and ascertain the contents of what it points to understand if it was quote unquote good, quote unquote useful. Maybe I've gone too far with this. Yes, it can be a good pointer, but finding out what it points to would require more code. You could have, yeah, you just dereference it and print it out to the console. Fuck it, why not? Who cares? It's fine. Why is initialization of p legal but that of 1p illegal? Well, it starts with the 1 for. It starts with the 1. It starts with the name starts with the 1. You can't do that. That's illegal. But ignoring that, maybe I'm pretty sure that's illegal. You can't start with a 1. You can't start with a number or was it a space or something? Space, white space doesn't matter. Int I equals 42, void star p equals and I, long star, such as a capital I then maybe, or L 1p, I don't know. The font they use is utter garbage. Oh, thank you. Well, that's a great place to leave it. Let me just finish up these little tasks. Understanding compound type declarations. Nope, we're done. We're done here. Oh, I don't have a Windows account. Right, yeah, of course. 30-day trial for evaluation purposes. Let me just. Oh, no, I wanna. There we go. These blocks input. Oh, we'll sort that out for next week, don't worry. Understanding compound type declarations. We've seen a variable definition because it's the base types and. Yeah. That's another thing. I didn't want my stars to be. Where'd you put it? Where'd you put my stars? I don't want my stars to be rambling against int. I hate that. Either with white space either side, or with a white space between the int. God damn it. Anyway, yeah, we've been around for about an hour. An hour of C is probably too much for one day. Let me just turn off this phone. Save the page. And we'll do our rundown. So we did brushed on compound types, but more importantly, mostly importantly, we finally, after decades of waiting, revisited pointers and references. We've created references to objects. We have created pointers to objects. We have dereferenced the contents of pointers. It's not really like that. They're not contents. They're pointers to dereference the information that the address that a pointer links to or points to. There. We've also extracted the memory address of the pointer by using the reference bedingle, and that's all great. We've got that saved in our chapter 2 C++ documento. You cannot download a license with streaming network connection. proxy settings. I've got plenty of internet, thank you. But yeah, thanks for dropping by if you came for the live video. Thanks for watching the video on demand. If these are not just completely and utterly madly boring for you, that's weird. I try and go back and watch some of this stuff sometimes, and I just go, my voice, my cadence, it's garbage. It's utter twaddle. It's not what people want to see. Anyway, it's not the point. Thanks for watching the VOD. If you did watch the VOD, you deserve a medal. I don't have medals to give out. And as always, I will see you in the next episode.